My name is Andrew Mitchler. Welcome to a presentation on AB Passive House Plus, which is a project that is near completion in Colorado. Principal of Hyperlocal Workshop based in Colorado, and we primarily work with residential and zero foam projects. This off-grid project is right in the foothills of Colorado. As I said, near completion, so you can tell by the photos. Right along the Front Range, about 2 mountains in from Fort Collins, Loveland area. The site is mountainous and treed and actually quite flat on the building site itself. So we were able to put quite a flat linear project down. And with the framing, what we're achieving to do is simplify it with a foundation system that's suspended. And that means that we have a crawl space, and we can use cellulose for the floor system and the wall system and the roof system. We're using a 2x6 wall frame that goes all the way down to the footings, and the outside are Larson trusses. And in fact, we ended up making this little how-to slide. Site has some rocks right behind the house. In fact, we're taking advantage of that by putting a bridge in to get over the roof to the house. Here's a rendering of that, what that bridge will look like, and the relationship with the trees and mountainside around it. The floor plan's quite open. It's 3 bedrooms. The main bedroom is lifted about 4 feet up above the main floor for privacy. As far as our energy modeling, the form factor is actually 4.5, but we have good solar gain in Colorado, and with a lot of aggressive shading to the southwest. And so construction begins on site. It was actually a pretty good dig. Foundation went in. It took some effort to get concrete crews up, but went fairly smoothly from there. It does still feel that we're putting a little too much concrete in these houses. They still feel a little over-engineered, in my opinion, and that's something that I'd like to target further, is the reduction of concrete. We did institute earth tubes into the project, about 300 linear feet of them for the ERV. That's also the cooling system. Here we're putting in the solar system for temporary to power the build. Basically, we're using nickel batteries and a traditional Outback solar inverter system. So the framing can be actually off-grid, which is very quiet, no generators needed. What we're doing is keeping the floor off of the foundation wall. So the foundation wall is actually a stem wall. Underneath is a generous crawl space to make it easier to get around. When you first get the framing in, it's nice to feel kind of the sketched effect of what the house is going to be. Here's the crew overlooking a good day of framing. And it's nice to get the feeling of how it works within the environment, especially in relationship with the rocks and the sun and everything. That foundation detail and that air tightness detail is a typical taped OSB layer to the 2x6 wall, and then outboard is all of our insulation, which is going into these 16-inch Larson truss cavities. We did have some sequencing issues that I think that should have been recertified. We need to make sure that we don't cover up our air barrier before we do proper testing, which happened here, unfortunately. But we were able to do quite a bit of air barrier work inside as well without disrupting the construction on the outside. As the windows go in, we're getting close to a complete thermal envelope as far as the air barrier is concerned. Windows are really heavy. These are from Wythe, based in New Jersey. There's a detail of one of the installs before it's overframed with the siding. Our first air test, we actually came in over about 1.3 ACH 50. So we had a lot to hunt down for air leaks. So we often use smoke. Doesn't take a hole. You can't even see the hole, but you can see smoke coming through it. Sometimes the framers get a little zealous Sometimes even small tape details, like right here where it goes through, air can come through. So we ended up using aero barrier at the end of the day to get a 0.11 ACH 50 is where they're able to get it down pressurized to. Now it's time for installation. Lots of cellulose insulation. The owners actually installed it themselves. We used about a truck's worth, 30,000 pounds. And you put it in any way you can. You can get quite creative because you always have more insulation to put in. Mechanical rooms. What we're looking at is basically a hot water condensing heater combo and water, domestic hot water. There's the Zehnder that just got installed or is in process of being installed. It's going to be connected directly to the earth tubes. That's going to be our solar electric hot water tank that we use for excess solar energy, and then some of the extra plumbing for the hydronic system. We have 4 actual zones to the space. So we have 3 that are for the bathrooms and 1 for the main living area, and then a post heater is going onto the Zehnder unit. Most of the building is clad with a standing seam metal, which is quite dynamic in the way it changes light. It's very clean, very good for water catchment as well, which is what this is being utilized for this house. That went quite well. Inside, here's the owner with her dog, and she really insisted on really thick walls, so we ended up not insulating the 2x6 wall inside to save time. So it's just on the Larson truss, which gives her a great sitting space. On the outside, we're actually using cork to the south side. It smells incredible. It's very much an ode to the idea of the house being very low carbon. Gives also a softness to the outside, especially where you're interfaced with the house where the sun is. To our great delight, it also doesn't overheat in the summertime. So it'd be exciting to see how it changes color and wears over time, but it's fun to always try new products. The windows inside, just about done, so we got good cross ventilation throughout the house. The interior space is really taking shape now. It's becoming, if it's a small space, I really believe that having a dynamic volume really helps the critical idea of making it feel much larger than it actually is. And of course, clustering the windows to the south, they're well shaded, but they give great view. So there's a sense of transparency right into the outdoors. I'm very happy with how that came together. Here's some details of some of the materiality coming together where you interface with the building. It's quite rich. This is where the rain catchment part of the roof needs to separate from the garage. It also provides, that gap also provides some natural light in what would be a very dark vestibule between the garage and the house on the north side of the building. So here we are looking north to the peak of the mountain there. The garage itself was very critical as far as part of the design. Almost put, it feels like, as much design effort into the architecture of the garage as we did to the house to make it really feel like it doesn't overwhelm the house itself. Again, here's the windows facing to the south and west in the bedroom up above. A very private but incredible view down to the valley and down to Denver. And here is the finished project as far as the exterior is concerned. A lot of detail and thought went into how the building is going to integrate with this particular very beautiful and pristine landscape. Of course, there is quite a bit of disruption when we build, so that's always a tension between the disruption of the architecture and how it can actually perhaps add a very comfortable and relevant feeling to the landscape itself.
By combining design and passive house technology as an architect, I can achieve more for my clients than ever before. Anyone renovating a building today wants appealing design, carbon responsibility, and resilience to Mother Nature. My client also wanted a day-lit home with high air quality free of pollen and the right balance of temperature and humidity throughout the year. Let my client take you on a tour of their renovated home that was originally built in 1948.
Hi, I'm the owner of this passive house in the Bronx. Here is the entrance. This mudroom used to be the garage, and you can see my family over there in the kitchen. This room has its own electric heating and a Lunos ventilator for ventilation that runs 24/7. We are walking into our guest bedroom and bathroom area. Through that door is the mechanical room, but before we go there, I want to show you the filtered air supply and return grills that keep the space comfortable with fresh air. In the bathroom, you will see a grill that draws air out, and over there in the bedroom, the round grill supplies fresh air, while the square grills supplies heating or cooling as needed. The whole house runs on electricity, including all our appliances, but here you can see the hot water heater, and over there is the ERV with the filters that are very easy for me to change whenever they are dirty. Over here is where the ERV supply and return air pipes go to the outside of the house, and there is a third pipe for our kitchen exhaust makeup air supply. The tubes here circulate the fresh air throughout the house, and I will show you more of the location later. Going back to the mudroom, we go up the stairs into the kitchen and family room, where you see my wife standing there in a line along the wall, where we remove the whole upper floor bedroom to open up the space. As you can see, the space is filled with natural light. The skylight above is 3 feet wide by 5 feet long, and it is triple pane with an exterior solar shade. You see another ERV ventilation air intake grill right there. In our home, the natural light is amazing, and it shifts through the house as we go through our day. These extra large windows face east to our garden, so we can see the trees and the sky. The trellis will shade against hot summer sun. My eldest son and I both have springtime allergies, but if we stay inside the house, they don't bother us. Here is the ERV ventilation control, and beside it is our Nest thermostat for central heating and cooling system. The ERV has a boost switch in each of the bathrooms and in the kitchen, and all we need to do is press it to get extra air circulation when we shower or cook. It automatically switches back to medium air circulation after 30 minutes, and there's also a vacation setting if we're away. This is the boys' bedroom. We exposed the old rafters to open up the space a little bit. The house was built in the late 1940s, and the wood aged really well, so I scraped it and cleaned it up and hung a swing. This is our master bedroom, and it used to be the living room of the old house. Next door is our combined walk-in closet and office, which originally was the front entrance and vestibule to the house. Back in our bedroom is the attic stair, which makes it very easy to go up and service the central HVAC system. This is our backyard, and you can see the stucco wall finish, which covers the new installation placed over the original exterior brick wall. When we bought the house, the inspection revealed that the asphalt roof required replacement, so we put 3 layers of new insulation board on top of the old roof and then put on new roof shingles, so the whole house exterior is insulated from the outside. This back corner is next to the mechanical room inside, and it is where the ERV supply and return pipes are located, as well as the kitchen hood makeup air intake. Thank you for watching, and I hope that this is informative of the amazing work that Lindsay put together for us. She is 100% dedicated to the passive house endeavor.
We're here today in Colombo, Sri Lanka, where behind me is one of our most exciting and interesting passive house projects. The Star Garment Product Development Center is a combination office and industrial building where both design, sourcing, pattern making, and sewing happen under one roof.
In South Asia, there's a long history of garment manufacturing, where working conditions in local factories are often hot, humid, noisy, and poorly ventilated. JPDA's work on the Star Garment Innovation Center uses Passive House standards to renovate an old factory to increase sustainability, reduce energy use and expenses, and improve the lives of employees. Passive House is a holistic set of design principles and efficiency standards that strictly regulate the amount of energy a building can use, guaranteeing a very high level of comfort for the people inside. Its basic principles include proper insulation to reduce heat transfer, an airtight enclosure to prevent leakages, high-performance windows and doors, and an energy-efficient heat recovery ventilation system. The Star Garment Building is located in the heart of Sri Lanka, just above the equator, where the tropical climate presents challenges to designing efficient, sustainable, and comfortable buildings. Renovating the old structure, rather than demolishing and building from scratch, dramatically reduced waste, carbon emissions, and fossil fuel consumption. The existing industrial shed was first stripped down to its bare steel skeleton and concrete slab on grade. Modifications were then made to the walls and structure, and the renovation included a high-performance heating, ventilation, and air conditioning system, a complete air barrier, continuous layers of insulation on all sides, high-performance windows and doors, and an insulated roof assembly with solar panels. Energy use is projected to drop by 70%, with a 90% reduction in dehumidification energy and a 73% reduction in heat pump energy. Employees enjoy year-round comfort in a workspace that provides filtered fresh air, abundant natural light, low humidity, and consistent temperatures. Studies by researchers at Harvard University showed that employees with access to properly ventilated air boast a 60% better job performance, have 30% fewer headaches and respiratory complaints, and sleep better at night. At JPDA, we are uniquely qualified in overseeing Passive House projects. We stand out for our close collaboration with a team of the world's leading sustainable experts and engineers. Unlike other sustainability standards like LEED, Passive House is evaluated through comprehensive performance testing before and after each project is complete to ensure the building holds up to the highest standards. With the Star Garments project, JPDA was able to use our expertise in sustainable methods of design to produce a state-of-the-art project that can be replicated on any building in any climate to make significant advancements in sustainability, energy efficiency, and quality of life for millions of people around the world.
Welcome to the Good Energy House. This is Tim Ayan, the owner of TE Studio Architecture, and I'm also the owner of the house. This is Minneapolis's first certified Passive House new home, and we built it in partnership with Tanner Construction and a number of gracious and wonderful other project team partners. Good Energy House replaces a dilapidated old home in northeast Minneapolis. Good Energy House is a two-story building. It features about 2,200 square feet. The main floor is an all-open living, kitchen, dining area with an additional guest bedroom / office and an accessible powder bath, as well as a mudroom that also hosts the mechanical system for the home. The living space is generously fenestrated. We have a vertical space in there with a little balcony up on the second floor, and the daylight in Minneapolis is wonderful, particularly in the winter months, and it can really penetrate that space deeply from the south and also from the west and illuminate the space basically all day long without artificial lighting. The second floor features 3 bedrooms and 2 bathrooms, one in a dedicated master suite, as well as our laundry space. Good Energy House is built in one of the more interesting climate zones on the planet with extreme winter and summer conditions. The foundation is entirely wrapped in EPS foam, and we spent a great deal of detailing and time on air sealing the building really well. While the foundation is built with insulated concrete forms, the exterior walls are essentially double stud wood framed walls that are cellulose filled, and the roof is a simple truss roof system that is also dense packed with cellulose insulation. The windows are German-made triple pane insulated frame units. They're installed into the structural frame of the building and over-insulated on the outside. I'll open this up here. So we have exterior motorized shades. I pointed that out on a couple of occasions here to control the heat that comes through the windows, also give us privacy, control glare. This is app controlled. We're working with Loxone. And Hella manufactures the shades themselves. Loxone is our control partner, and what we can do here in the app is we can drill down to a room and decide we're going to send this into shading mode. And now you can see the shade starting to move, and what it's going to do here is it's going to come down all the way and then right back up so that the individual slats go into a position that is based on today's sun angles to perfectly shade this room while maximizing daylight. And that's one of the great things of working with a strong controls partner, in this case Loxone. They have all this built into their product. This thing is smart enough to shade individual windows based on sun and indoor temperature in our home. It could do that individually for each facade as well. So in the morning on the east, midday on the south, and then in the evening on the west side. And you can see it shows the perfect shading position. At any moment in time, we can override this to our heart's content. We can send the unit all the way up or send it all the way down into privacy or night mode. I'm gonna close it right now so you can see what that is like. And just for completeness sake, I thought I'd give you the numbers here as well. The airtightness strategy worked really well in this house. We achieved a 0.22 ACH 50, and in general, we met all the Passive House criteria for the home. Currently, there's no PV system installed on the roof for a Passive House Plus certification, as we are completely powered by wind power. So the energy that the house does need is provided by a Mitsubishi Cold Climate air-to-air heat pump. These units are very well suited for our extreme climate zone. There's one outdoor unit that connects to an indoor vertical air handler. We also have one mini split head in the garage, which is super insulated and air sealed as well. There's an additional dehumidifier as shown here, as well as a smart thermostat to control the entire heating, cooling, and dehumidification system. Hot water is produced by an electric tanked heat pump hot water heater. It is also connected to a wastewater heat recovery unit that pre-warms the city water that comes into the unit. So on the second floor, on the north side, we decided to make an upstairs laundry space. So we have a washer and a dryer side by side. It's a high efficiency washer with a heat pump dryer, which is really the best choice currently for a passive house. So this unit, extremely energy efficient and little waste heat, and obviously the main selling point, there's no exhaust. So the effluent from the machine goes into the same drain as the effluent from the washer. So next to washer and dryer, we have our Zehnder Q Series ERV. These are the lungs of the building. This is the heat recovery ventilator. It's a very basic setup in this house. We were able to bring the air from the outside right into the machine through the wall. So we have perhaps the world's shortest air intake at, I think, a couple of inches before the elbow. This here in the front is the exhaust. So this is the stale air from the house being brought back to the outside. And then to the right here, we have the manifolds. The one in the front is the return from the house. Behind it are the supplies. There's a total of 20 home run pipes. The supplies go to bedrooms and living spaces. The returns, basically kitchen, bathrooms. And the machine is the latest from Zehnder. It's a very efficient heat recovery core, energy recovery, I should say. It's an ERV version with over 90% recovery potential in the core, and a very great interface that's app-based, and it's just a pleasure to commission and run and operate. Alright, with the induction cooktop and the oven down below, we also decided to install a recirculating range hood. These things are great. They don't have an exhaust, which doesn't work in a passive house. We do exhaust with our ventilation system, which happens to have an inlet right above me. So this is what transports the air to the outside with heat recovery in the winter and heat recovery, or cool recovery, I should say, and moisture rejection in the summer. And just some final thoughts. The Good Energy House is a carbon neutral site. We also used extensively sustainable and renewable materials and local resources to make this building, as we always do in our practice. The goal is to blend economy and efficiency as well as sustainability and create something that is beautiful and that people will enjoy well into the future and care for. Well, thanks for joining the tour today, and goodbye.
Well, hello to everybody who hangs out in buildings, and a special welcome to everybody who's interested in Passive House. I'd like to share with you a real-world success story of what happens when you apply high temperatures to a super insulated building. Alright, this is it. A little granny flat in a Northern California backyard. It's pretty small, as you can see, but the owners had some really high ambitions for the place. We can talk about some of those in other videos. Right now, I'd like to talk about how they wanted to get to an ultra-low energy use building. It's under construction right now, so you're going to get a behind-the-scenes tour. Come on in. So what's the best way to make a low energy use building? You make sure that the roof and the walls, architects call that the envelope, do a really good job of keeping the outside out. And what's the best way of doing that? Using Passive House principles. So you'd think, oh, it's a tiny place in a mild climate, piece of cake. But we were still a little bit nervous about it. We had designed it to have not any air conditioning. We weren't 100% certain that it was going to work. This was also the first time that the construction crew had taken on this kind of project. And finally, we were nervous because it's actually this small. It's kind of counterintuitive, but really small buildings, because of their higher surface to volume ratio, can make it harder to hit Passive House targets. Okay, so before I tell you what happened, let's do a deep dive into the details of how we actually built the place. I got a little bag of souvenirs here. So on the outside, we have this corrugated metal siding, and the siding is attached to these pieces, which are called Z-girts. You kind of see why. And the Z-girts, instead of being attached directly to the side of the building, were put onto these little fiberglass standoffs. Now the fiberglass part of it is kind of important because that means that I don't have really conducting metal going from the outside to my building. And the fact that it's got all this room there means that I could put in 4 inches of this stuff, which is mineral wool insulation. Then we get to this stuff. These are little sheet membranes, sticky stuff. We use the orange stuff on the walls and we use the red version on the roof. And it is our primary air and water barrier. It turns out that it's just as important to keep the air out of the building as it is to keep the water out. So you want to be really careful about that. And that means use a whole lot of this special tape to seal up all the cracks and the little holes and things that you find. Okay, so there you go. So there's our membrane stuck to the side of plywood. And the plywood is then nailed to some wooden studs. See? And the studs sit on top of wooden sill plates. And we used redwood instead of pressure treated wood. And underneath, got stapled these gaskets. And the gaskets stop the wood from being in contact with the concrete of the foundation. And they also stop any air leaks coming through sideways. So we got that going on. And then on the inside, in between the studs, we stuffed it with this wonderful fun stuff. This is sheep's wool insulation. Then we did another passive house trick. On the front of those studs, we put up this furring horizontally, like this. And what that does is it gives a space to put all your electrical and plumbing so that the structure is completely intact and there's more room for insulation inside. And then on the front of that, of course, you end up with your final finish, which in this case, for us, was this walnut veneer plywood. And there's one little place in our hut, because we have this funny little secret dog window, where you can still see that.
Before we'd put all the insulation in, a guy came out with some test equipment, a blower door, to actually test how well we'd managed to seal the envelope against air leaks. We were aiming for 0.6 air changes per hour at 50 pascals of pressure and sailed in at 0.45. That's awesome. All right, so here we are with a nice envelope all done up, but we haven't got any of the ventilation system in place. You can see the thermostat there, which is connected to heating panels on the ceiling. And you can see the empty loft there with a couple of tubes sticking out of the wall. They're covered in painter's tape right now, where the ventilation equipment is supposed to go. And then we got hit with a real spell of really hot weather. And look what happened. The place was all closed up, even at night when the outside temperatures dropped. And the inside temperature barely budged, even after nearly a week of hot temperatures. There was nothing active going on to cool down the place, and it still stayed comfortable inside.
And you know what? It's even harder to take the heat out of the place than it is to add it in, which means that having a summer sweater on your building is going to be really welcome when the weather turns cold. There you have it. Clear, solid proof that air sealing and insulating according to Passive House principles totally rocks. This works, it's awesome, and you want it. And here's why. Up front, you can buy much smaller equipment for the lesser amounts of active heating and cooling that you actually will need in a building like this. Because that equipment is smaller, and because it'll be running less, your operating costs will be less. And because the wooden structure, or whatever other structure you've got going on, is better protected behind the air barriers and all the insulation, there will be less costly repairs down the road. It always works because there's nothing to break. It works in power outages. It works in extreme weather events. That means the whole place is more resilient, and that is a measure of safety. Because the interior is more stable and uniform, the building is more durable. And because there's less demand for energy, the entire grid has less strain put on it. Because there's no weird air currents or hot and cold spots, you can sit anywhere in a building like this and be comfortable. And it's quiet two ways. There's no mechanical system that's going to be clanging and banging all over the place. And the insulation reduces all that outside noise. And finally, you're breathing fresh air straight from the outside. It's not coming in through walls that are filled with dust and mold, or coming in through a crawl space filled with spiders and mildew and maybe even radon gas. Because there's so much less energy demanded from a building like this, there's less pollution coming from power plants. And because the buildings are more durable and people like them more, there's less demolition and waste. Thanks to Laurel Architecture and Canyon Construction for making it happen in this case. Ask for a high-performance building envelope the next time you're building, or remodeling, or buying a place. It's totally worth paying attention to the details. And if you're a building professional, challenge yourself. It's totally doable.
Welcome to Passive House Los Angeles. I grew up in Berlin and studied architecture in Germany, where I was early on exposed to the Passive House construction standard. In 2010, with Paravan Architects, we had our first Passive House approved in Los Angeles. It's a small community center, which unfortunately became a victim of the great financial recession. Since that time, I always have tried to educate clients about the advantages and the comfort to build to Passive House standard. But none of my clients wanted to be a guinea pig and wanted to be the first one here in LA to build a Passive House. When my wife and I were looking to purchase a property, for us it was always clear that we wanted to share the property and, of course, the mortgage. In 2013, we bought a 6,000 square feet property with a small 1,000 square feet typical building in the front portion of the lot. When it was time to plan for the new second house in the rear of the property, it was clear it has to be built to Passive House standard. This time I had to convince only my wife, and the argument of comfort and low utility bills did the trick very quickly. At the same time, it was important for me to create a showcase or a case study that I can test drive with potential clients and bring them into a building and show them how well a Passive House building is performing. Since the opening and during construction, we had already hundreds of people in the building. Passive House LA is 1,750 square feet large. It has 4 bedrooms and 3 baths. We have to say that the bedroom on the first floor is currently used as a home office, and the bathroom on the first floor is fully wheelchair accessible should that be needed at any time in the future. On the first floor we have the kitchen, open dining room and large living room with large windows covered by exterior shades which are fully automated in order to block the sun and keep the Southern California heat outside the building. On the second floor you see the outdoor deck, which is at the same time the cover for the required carport. We have a gallery for the large book collection, and then the master suite with the master bathroom attached. The bathroom on the second floor is very compact. In order to save more floor space, we combined shower and bathtub, so you need to walk through the shower in order to reach the bathtub. The building is an all-electric home, so we do not have any gas for cooking. We are using an induction cooktop, and also for the laundry, for the dryer, we are using a condensation dryer. Passive House LA is a wood frame building. The exterior walls are framed by 2x6 members, and the building is sitting on a slab-on grade with an R10 foam insulation below. The cavities in the walls are filled with blow-on insulation, and on the exterior we have a continuous rock wool insulation with a rain screen and metal facade finishing the building. On the roof we have a TPO roof enclosing the building. In terms of building systems, we're using a heat pump water heater with recirculation pump. Each bathroom has a motion sensor installed, and that triggers the recirculation pump, and this way we have immediately hot water at the tap. For the heating and cooling in the building, we are using a one mini split system for the entire house. The house is 1750 square feet, and we actually had an open house, which was quite interesting, and we had the representative from the air conditioning company out here asking, how do I like the system? And I had to tell him, I don't really know. I rarely use it because it's most of the time not needed, and the ventilation system, the heat recovery ventilation, does pretty well here in order to provide sufficient airflow and comfort in the building. For the continuous ventilation, we have a Comfort Air 550 in the building with a MERV 13 filter. During the construction and also in the end at the final door blower test, those are always nerve-wracking moments in the process of a passive house. Turned out we came in at 0.48. For us, it was very important to have a lot of daylight in the building. Especially in Southern California, it is critical that you have to have large windows if you want to have a building which is succeeding in the local market here. That meant large windows, lots of daylight into the building, that we needed to come up with an exterior shading strategy. Most people do not have exterior shading here, which is very surprising to me, because if the heat is in the building, it's too late, and we typically solved with bigger air conditionings in the past. But shading belongs on the outside, and we choose an automated Venetian blind shading system, which fully operates automatically. We have a roof sensor which tracks the sun and is adjusting the blinds as needed. The great part about that one is we are still getting daylight into the building, and at the same time we still can look outside the building. You will see also in the videos we don't have any interior curtains. We're using the exterior blinds also as our privacy screen, which works very well. In terms of on-site renewable energy production, we have 16 solar panels on the flat roof. We are net zero with only 10 solar panels, and we also have a battery backup system. So the solar panels are feeding the battery backup system, and the disconnect is located behind the battery. So even during a power outage, the solar panels keep feeding the battery, and the house can draw via a critical load panel the generated power, so we have an independence should be there a power outage for a longer time. Thank you for joining us on this virtual tour of Passive House Los Angeles. Please feel free to visit us also online at www.passivehousela.com.
Hello everyone, welcome to the National Green Intelligent Building Demonstration Center. This center covers a total area about 17,000 square meters. It is a comprehensive demonstration center and the professional popular science base for environmental protection and super energy conservation of buildings, which is built by Orange Thunder Group. The park includes the Sponge City model and the first passive house exhibition building in Asia. The pavement is made of exposed aggregate concrete. The advantage of this pavement is rainwater can quickly penetrate and supplement of the surface water. Let me show you around. Here is a home tree nest. It is a rainwater collection tower. The 5 towers can store a total of 158 cubic meters of clean water and use gravity water pressure to irrigate the surrounding plants. Please follow with me. Now we're at the Square of Passive House Museum, and it exhibits the model of old Gaobeidian City. Now let's go inside of the museum. Now we are at the Same Museum of Actual Low Energy Consumption building. This is built according to German PHI standard. The exterior facade is composed of 133 wind shading shutters, which can automatically adjust the angle with the sun's altitude angle, as well as indoor and outdoor temperature. This museum is the first passive exhibition building in Asia which obtained PHI certification. Here is a wooden cable curtain wall system. The air tightness is at the highest level of Chinese standards. The heat transfer coefficient is less than 0.8, and it is the highest single wood passive curtain wall in Asia. Here is a model of modern architecture. We rely on air conditioning, heating system, air purifiers, and other equipment to achieve a proper indoor environment, when in fact it's not necessary for us to use them. There are 3 problems of traditional housing. First, poor insulation performance. Second, the obvious cold and thermal breach effect. Third, the bad air tightness of the house. Please go this way with me. We have set up the collection equipment of multiple environmental monitoring data inside and outside the museum, where we can see the angle of sunshade system corresponding to indoor and outdoor temperature sunshade angle, energy consumption of fresh air equipment, and so on. Here is the first design principle of passive house, excellent thermal insulation performance. The left and right boxes represent the insulation layer and non-insulation layer respectively. Touching the aluminum plate, we can find it is much hotter than the ordinary building with poor thermal insulation than passive house with good thermal insulation layer. SIG SEPS puts on a warm coat for the building. Please go after me. Second, this device simulates the heat transfer of the cold and thermal breach. It can be seen that heat conduction will transfer heat with the same color of energy, while the insulator will avoid heat transfer without affecting each other. Third, good air tightness design could prevent indoor and outdoor hot and cold air penetration. From the shape of the gas in the glass, we can see the difference. Then I will show you about the integrated environment control unit combined heat pump with outdoor air system. This area shows integrated environment control unit combined heat pump with outdoor air system with heat recovery. This demonstrates the principle of heat exchange of fresh air system with water accumulation simulation. Finally, high-effect and energy-saving door and window system can effectively isolate noise. We put the same noise equipment in the window. Open the window, we can feel the difference of sound isolation effect between the ordinary window and the passive window. Because of the passive house can achieve the goal of actual low energy consumption operation, it has been widely promoted around the world. Here shows the successful cases at home and abroad. Passive architecture is a major trend in the future. Here is a real-time monitoring of the entire building of Passive House Museum. we have built a simulation room according to the passive house specifications. In this room, we have simulated the outdoor temperature in winter and summer. You can touch the window glass to feel the excellent thermal isolation performance of the passive house window. Let me show you about the air tightness. The glass house demonstrates the air tightness of the passive house and the indoor air replacement of the integrated environment control uni-combat heat pump with outdoor air system. The following is a display of the important nodes in the construction process of passive house. First is the external thermal insulation wall system. We not only use a thicker thermal insulation layer than the conventional building on the external wall, but also on the ground, basement, and roof, so that the house has excellent thermal insulation performance. This ventilation machine is researched and developed by Locarno Company. It is a full replacement integrated environment control uni-combat heat pump with outdoor air system with heat recovery. It is the first internationally certified passive house ventilation machine in the world. Here is the isolation method of window hanging outside. The window is connected with the wall through the isolation subframe, which can avoid a cold and thermal bridge between the window and the wall. This is all about the Passive House Museum of our National Green Intelligence Building. Making the building more energy saving and making life getting better. We welcome you to visit our group. Thank you.